Today we will be talking about tables of proportional relationships. Remember, a proportional relationships are ratios that are equivalent all the way through. Okay, so let's take a look at number one. Misty is buying shirts for her doll that cost 3 for $5. So 3 shirts cost $5. Okay, so we're going to fill out this table to represent that and determine if the relationship is proportional. Okay, so if we buy 0 shirts, that is going to cost $0. But if we buy 3 shirts, it's going to cost $5, which they tell us. 6 shirts would cost $10. And 9 shirts would cost $15. And we can see that my change in y, so x value, y value, my change in y value is 5, and my change in x value is 3. Change in y is 5, change in x is 3. And if we simplify each of those ratios, you can see that they all are exactly the same or would simplify to be the same. Okay, so yes, this is a proportional relationship. All right. Also, proportional relationships are going to go through the point 0, 0 and increase evenly throughout. Okay, so let's take a look at number 2. Each avocado at the store costs 50 cents. So one avocado costs 50 cents. 2 avocados cost $1 because that's 50 cents times 2. 3 costs $1.50, again, 50 cents times 3. And 4 avocados cost 2. And you could add another little section here that 0 avocados would then cost $2. Okay, and we can see that our increase is that 0.5 or half for every 1, and that remains true throughout. Okay, so this is, yes, a proportional relationship. All right, so it has 0, 0, and it is a constant rate of change throughout. Okay, so Bronk reaches into the box of colored pencils. In the box, there are 5 red pencils for every 4 blue pencils. 5 to 4. Well, if there's 10 red pencils, well, there should be 8 blue pencils. 12 and 16. Okay, and again, because it stays the same throughout, it would be proportional. Okay, and there are several more that you can find here. I do want to take a look at number 6 here. It says Cynthia has a monthly cell phone bill of $35 plus $5 per 100 minutes. So this $35 is regardless of her using any minutes of phone service whatsoever. So $35, 0 minutes costs her $35. Then $5 per 10 minutes. So we start at that 35. She's going to pay $40 for 100. She's going to pay 45 for 200, and she's going to pay $50 for 300 minutes of phone usage. Okay. Now we take a look. First thing, this is not 0, 0. So that tells us right away this is not going to be proportional. Okay. And we could also see here 35, it goes up 5, this goes up 100. This does stay the same throughout, but again, because this is not 0, 0, it is not true. Okay, you can also see here that 40 divided by 100 is 0.4. 45 divided by 200 is 0.225. And 50 divided by 300 is 0.16 repeating. Okay, and these are not the same. Therefore, this is not proportional. Okay, so that's 2 different ways. If we go back up and look here at number 3, we can see we not only noticed that they were all the same, we had 0, 0 as one of our options, but 4 divided by 5 is 0.8. 8 divided by 10 is also 0.8. 12 divided by 15, you guessed it, 0.8. 16 divided by 20 is also 0.8. Okay, so those ratios stay the same throughout if you convert those into decimals. Okay, let's take a look at one more here, number 7. Dakota is selling his trade cards. He will sell the first 5 cards for $3 and each card after that for $1. So he will sell the first 5 cards for $3. Then each card after that, so one more card, he's only going to sell $4, and then one more card, 5, and then 6, and so on from there. Okay. Now, if we take a look again at these ratios, they're the same. Our y divided by x is the same here. So let's take a look. 3 divided by 5 is 0.6. 4 divided by 6 is 0.3 repeating. Okay. And then you can see that these are already different. So this is no, not proportional. Okay. All right, there are several more that you can take a look at there if you would like to. We're going to move on down to number 11. Okay, we're going to take a look at number 11. This is asking us about the constant of proportionality, okay? This is asking cost per granola bar. So we have 3 granola bars for $5. So 3 granola bars for $5. 9 granola bars for $15. We could also fill in a table here. 6 granola bars for $10. Now this is asking for the constant proportionality per granola bar, okay? Which means granola bars is actually going to go on bottom. So we're going to look at our change in our Y value, which is dollars, over our granola bars, which is our X value. So we're going to have 5 granola bars, or sorry, $5 for 3 granola bars, okay? And that is our simplified ratio every single time, okay? So basically you're getting 1 2/3 granola bar, or 1 2/3 dollars per granola bar, or 1.67 approximately dollars. Okay, so 5/3, 1 2/3, or approximately $1.67 per granola bar. Okay, number 12, let's take a look. Damien can make 3 free throw shots in 10 seconds and 18 free throw shots in 1 minute. What is the constant of proportionality for shots per second? Okay, so I'm going to change this 1 minute to 60 seconds. So I have 3 free throws in 10 seconds. I have 18 free throws in 60 seconds. Okay, so per second, we're going to keep our seconds on the bottom because it's asking shots per second, which means shots goes on top. Per second can stay on the bottom. So we have 3 tenths, and then 18 over 60 also simplifies to 3 tenths, and that cannot simplify any further. So your constant of proportionality is 3 tenths. You can also see 3 to 18, your increase is 15, and over 50, and that simplifies to 3 tenths as well. Okay. Another way to think of constant proportionality, again, is cost per one. So you can see each of these are asking per shirt, per second, per granola bar. Okay, so again, unit rate. So Timberly buys 4 shirts for $31 and Riley buys 7 shirts for $54.25. What is the constant of proportionality per shirt? So Because this is asking cost per shirt, we can go ahead and put cost on top, $31 for 4 shirts and $54.25 for 7 shirts. And again, if we simplify this, we can do 31 divided by 4, and that gives me $7.75 for one shirt. And I want to make sure that it's the same for the other one, so I'm going to do $54.25 divided by 7 is also $7.75. So my constant of proportionality per shirt is $7.75. Again, order matters on these. So we're doing cost per shirt, which means cost over shirts. This first one I had listed as granola over dollars, but I went back and we used dollars per granola when we figured out our constant proportionality. Okay, there's another example there if you'd like to try that. Okay. Okay, we're going to come down to number 15 here. It says the table shows the amount of money Akahana will have to spend based on the amount of tickets to the musical she buys. Use the table to find the constant proportionality for costs per ticket. Okay, so we have $36.50 for 2 tickets, $73 for 4 tickets. So first let's make sure this is proportional relationship. Okay, so 73 minus 36.50, and that's 36.50 for 2 tickets. Okay, and we can see that that continues throughout here. Okay, and we can also take 36.50 divided by 2. Those are all going to simplify, and one ticket is going to cost us $18.25. Again, we can find that 2 different ways. We can take our change in Y over our change in X because again, cost per ticket, which means cost goes on top, $36.50 for 2 tickets. Okay, and that simplifies to $18.25 for 1 ticket. Okay, and you can see it would be the same if you take the 146 over 8, because again, it is a proportional relationship. You would still get $18.25 for 1 ticket. Okay, so constant of proportionality is $18.25 per ticket. Okay. All right, and you can try those last 2 on your own if you would like.